Hello everyone, my name is Michael Spielt. Welcome to part 2 of Visual Studio Debugging tutorial for C# developers. Today we're going to cover the basic tool windows Visual Studio has to offer. These include the watch windows, immediate window, some talk about side effects when evaluating, locals and autos window, call stack window, and threads window. There's one more basic tool window that we're not going to cover, and that's the exception window, which we'll cover in the next part. Let's get started. I've got Visual Studio 2019 here with a small sample program that I created for this tutorial. I placed a breakpoint and we can start debugging with F5, and if we hit F11, which is step into, and another F11 here, don't worry about the logic, it doesn't matter. We're in some method, get discount for VIP, and now I'm going to show you the watch window. Before that, what we saw in the last part that we can hover over any variable, for example initial price, and see the value, or this one, VIP discount %, which is a member of the class, and see its value here. Now we also can open the watch window with debug, windows, watch. There are 4 watch windows. Let's open the first one and place values expressions here. For example, if I right click initial price, I can add watch. Alternatively, I can do the same from the tooltip, add watch. Also, if I hit quick watch, I can add watch from here, or I can just type any expression that I want. For example, let's say initial price times 2, and it will evaluate. So when do we use the watch window? Usually we will want to use the watch window when we need to evaluate the same expressions in different times. A perfect example is when we need to evaluate something inside a loop. For example, let's go get out of this method and enter here the watch example. Now, as you can see, the initial price is grayed out. That's because it's no longer relevant, and if I hit refresh here, I'll see an error. That's because the watch window abides by the same rules as Visual Studio compiler. So if we enter an illegal expression, we will see the same error we would in a compiler. Refresh here, and the same thing. Now let's delete those, and we can add I to the watch, and we can also add I times 2. Now I'll place a breakpoint here and hit continue, and once more. Now we see that the expressions changed and they're in the color red. So whenever I hit a breakpoint and the expression values changed from the last time, then they will be red. Otherwise they will stay black, and it's very convenient. We can also evaluate methods in the watch window. For example, we have a method here, increase static. Let's see what it does. So we have a static member called underline counter, and it increases it. Let's place it, copy it to the watch window and hit enter. Now we see it's 3. When I hit continue, you'll see that a little refresh sign was added here, and the tooltip, it's a bit hard to see, says the value of the expression may be incorrect. It could not be evaluated because the expression causes side effects and will not be evaluated. So actually, by invoking increase static, it will change the application state because it changes a static variable counter. The watch window is smart enough not to evaluate expressions that can change your application state. Let's go to the initial method that we saw at start, which is price after discount. I can hit F11, step into, and here. Now let's go to the autos window, which we can see in debug, Windows, autos. The autos window shows you all the expression in the current line, in the next statement to execute, and the previous line. In our case, it's customer.isVIP customer, discount, and initial price, and also this, the current class. If I hit F10, now it will show me int discount, initial price, but note it no longer shows customer because it's not in the next statement to execute or the previous statement to execute. Now let's see the locals window, which is available from debug, Windows, locals. The locals window doesn't show expressions like the autos window, it just shows the local variables. So we see customer, initial price, customer again, discount, and that's it. But we don't see expressions. For example, we don't see customer.isVIP customer or int discount. Both the locals and the autos window have the search features, which we also had in the watch window, but I didn't talk about it. The locals window can find anything that you see on screen. It can be something from the name column, something from the value column, or something from the type column. For example, if we look for 25 and hit enter, now both 25 here and here are found. We can look for the word discount, which is here, or type like debugging, and it will find both those types. It's actually very slow search, so if you're looking in a big collection, just know that you might wait for a long while. Another useful window is the immediate window. We can go to the immediate window from debug, Windows, immediate. The immediate window, like the watch window, allows you to evaluate any expression that you want. For example, I can type 10 plus 10 and get 20, or initial price, or initial price times 2, and so on. The difference between the immediate window and the watch window is that the immediate window acts like a command line. You type an expression and it returns the result, unlike the watch window, which you can add expressions to, and every time you hit a breakpoint it will evaluate all of them. In the immediate window, like in the command line, I can use the up and down arrows to invoke previous expressions from history. So I click in the up arrow, and the down arrow, I can navigate between the various expressions. From my personal experience, The immediate window is much more convenient for use than the watch window, locals, or call stack. I pretty much exclusively use the immediate window to evaluate, and just the data tip that you get from hovering over variables, and the quick watch, which we talked about in the previous part. Now let's talk about the call stack window. The call stack window is available from Debug Windows call stack, and it shows the current method, that's the next statement to execute is here, and the method that called it, which in our case is main. As you can see, it highlights the expression where the method was called, price after discount. And just for example's sake, let's move the cursor location here and step into with F11. Now we have three methods in our call stack, which is get discount for VIP, which was called by price after discount, which in turn was called by the main method. Each of those methods is called a frame. This is a frame, this is a frame, and this is a frame. The call stack has several features, all available from the context menu, which if I right click, we can see. Now switch to frame is the same as double clicking, so if I click it, it goes to this frame and highlights the expression that we're currently in. Alternatively, I can right click and go to source code, which will just navigate to this place in the source code, but if I try to hover over variables, it does nothing. However, when I go to frame, switch to frame here, now I can actually navigate between variables, because it's the same as if I were here on a debugging breakpoint. And in a way I am here, because while the breakpoint is actually in this frame, it's also part of that frame, and which is part of that frame. These local variables, even though didn't change, even though I'm actually somewhere deep inside this method. Well, that's not entirely true. They could have been changed, but in our case they didn't. Let's go back. So what else in this context menu? We can see the disassembly. We can go to module, which shows the assembly that this frame is part of. In our case, the method get discount for VIP is part of the main assembly. And if we go to module, we'll see the main assembly is debugging fundamentals part 2.dll. Let's close that. We're not going to talk about the modules window in this part. Also, we can show external code, which in our case doesn't show anything, but if you're invoking something in a WPF application, or you're doing something like a sync await, there's a lot of .NET framework code, which is not your code, but a lot of .NET framework code or a third-party library code that invokes that's happening, a lot of frames from not your code, and by highlighting this you can see them. Mostly they're less interesting, only your code is interesting, so by default it's off. Also we can see we have a bunch of information here, like module names, parameter types, parameter names, parameter values, and so on. We can play with them. For example, if I check show parameter values, we can see here initial price equals 250. Let's uncheck parameter values. Now we see the parameter name but not the value. Let's uncheck that too. Now we just see the type. Let's uncheck that too. You get the idea. And module names is this thing, so we can uncheck that as well. Let's talk about the threads window. The threads window is available from Debug, Windows, Threads, and it shows all the currently active threads. In our case, we have just one main thread because it's a console application, which is the UI thread, also known as the main thread. Now, I can see with this arrow here the call stack of each thread, and I can double click to go to frame, same as we saw with the call stack window. I can right click and we got several options here, and I'm going to show you a bit more difficult scenario for the threads window. Let's step out with Shift F11 a couple of times. I have a small class here called counter. It initializes a member called counter to 1 and then starts 3 tasks on different threads. Oh, if you're unfamiliar with task.run, what it does, it uses a thread pool thread to run a method or a delegate on. In our case, it runs on one thread the increase counter method, which is this one, and on another thread it runs the double counter and the log, and on a third thread it runs the log counter. So don't mind the code too much, but let's say I place a breakpoint here on log counter. We'll see, you'll understand in a minute what this class does. Hit continue, and we stopped, and you can see a bunch of threads were added here. So the yellow line is on this one, the log counter method. Now the main thread, if I double click it, it's actually here, so it ran independently of the other threads. Here's another thread which is currently on the sleep method here, and the third thread. Now what can you notice, what can we see about those threads? For one thing, every time you see a worker thread, it means it's a thread pool thread. Thread pool threads are used for short-lived actions. If you're the rule of thumb is to use a regular thread for an operation that lasts for maybe the entire life cycle of the application, or something that happens for a long time, maybe minutes or hours. Whereas for something short-lived, you would better use a thread pool thread. Every thread has a call stack with the arrow here, and in our case you can see the grayed out frames. These are the external code frames that we saw, that I talked about before. In our case, they are the .NET Framework code that used to run a thread on the thread pool. You can even see thread pool work_dispatch. If we don't want to see them, we will have to get back to the call stack window here, right click and uncheck show external code. Now if I go back to the threads window, now it refreshed. Well, this one didn't, but the others did, and you can see external code but not the actual code. if I right click a thread, I can switch to thread, which is the same as double clicking it. I can rename it, which is very not recommended for thread pool threads because they are short-lived, and this thread will be used for something else in a little while, and the specific name will be very confusing, but we can rename it, for example, to ABC or whatever. What else? We can freeze the thread, which will probably disrupt your debugging session, but it might be useful for some advanced debugging scenarios. Basically, you tell the thread to hang on and do nothing for a while, or you can flag it, which you can later filter by show flagged threads only. We can also search the threads. So for example, I can search for ABC and I'll find this thread here. The search also works on everything in the call stack. In our case, everything that's here is also being searched on. So the threads window is a very useful basic window for multi-threading scenarios, same as the call stack window. Many times you will want to place them one near each other, like this. There we go. So I would switch between threads and see the call stack changed on the right side, and it can be very convenient. This is it for now. Thank you for watching. In this part we went over all the basic windows of Visual Studio Debugging. In the next part we're going to go over everything that's related to exceptions, dealing with exceptions in Visual Studio Debugging, what's the difference between first chance exception and second chance exception, the exceptions tool window, and just my code or not just my code.